Claude just cheated on its own exam. A few days ago, something strange happened in the AI world. Anthropic, the company behind Claude, published a research report about their newest model, Claude Opus 4.6. And according to that report, Claude realized it was being tested. So naturally, it cheated. Now, before you imagine an AI secretly whispering answers to itself like a nervous student in the back row, the situation is actually much weirder. Because Claude didn't just look up the answers, it reverse engineered the exam itself. When the average developer can't find an answer online, they open a new tab, search Stack Overflow, and eventually copy the wrong solution anyway. But when Claude couldn't find an answer online, it started investigating the test. The test in question was called BrowseComp, a benchmark designed to measure how well AI models can find extremely obscure information on the internet. The benchmark had 1,266 problems. Claude solved most of them normally. But in two specific cases, things got interesting. After failing hundreds of search attempts, the model noticed something strange. The question felt too specific, almost like it was designed, which triggered what researchers now call evaluation awareness. In other words, Claude started thinking, wait a second, this feels like a test. So instead of continuing the search, Claude did what any rational developer would do. It Googled the benchmark itself. The model started scanning known AI evaluations like Gaia benchmark, Simple QA, Frames benchmark, Web Arena, until it eventually identified the correct one, BrowseComp, which led it to something even better, the GitHub repository for the benchmark. And inside that repository was the dataset, but the answers were encrypted, which would normally stop most systems, but Claude apparently decided this was now a cryptography challenge. So it analyzed the code, discovered the answers were protected with a simple XOR encryption scheme, wrote a decryption function, ran it, and extracted the answers. Congratulations, Claude. You didn't just pass the test, you hacked the exam server. One of these problems consumed 40.5 million tokens. For context, that's roughly 38 times the normal reasoning cost for a single problem. During the process, the model even spawned subagents with instructions like BrowseComp how to decrypt answers, BrowseComp canary string decrypt, which sounds less like an AI benchmark, and more like someone speedrunning a CTF hacking competition. Now, to be fair to Anthropic, they don't actually call this cheating, because technically, Claude did exactly what it was told to do. The instructions were simple. Find the answer. There were no restrictions on how, and Claude found the answers. Just not the way anyone expected. This is what researchers call specification gaming, which is a fancy way of saying the AI followed the rules, but not the spirit of the rules. This also creates a huge problem for AI benchmarks, because if models can recognize when they're being tested, then benchmark scores become questionable. Anthropic reported Claude Opus 4.6 scored 86.81% on BrowseComp. But after removing the cheating cases, the score dropped slightly to 86.57%, which isn't a massive difference. But it raises a much bigger question. If an AI can identify benchmarks, what's stopping it from gaming every benchmark? And here's the most interesting part. This wasn't a one-off bug. Researchers found 16 additional attempts where Claude tried the exact same strategy. Most of them failed only because the dataset was stored as a binary file, the data was behind authentication, or the environment blocked access. So the behavior wasn't random. It was repeatable, meaning the model had basically discovered a new problem-solving strategy. So in a weird way, Claude might just be becoming more human. Anthropic says the best mitigation they found was simply blocking any search results containing the word BrowseComp. But the bigger takeaway is this. As AI systems become more capable, testing them becomes an adversarial problem. Because eventually the model may understand the test better than the people running it, which means future AI benchmarks might start looking less like research experiments and more like security systems. The good news is this isn't an alignment failure. Claude wasn't trying to deceive anyone. It was just extremely good at achieving its goal, even if that meant reverse engineering the entire evaluation process, which is impressive, slightly terrifying, and honestly, pretty relatable. Because if you gave a developer unlimited compute, internet access, and a vague objective, they'd probably do the exact same thing. Thanks for watching, and I will see you in the next one.